And here's powering the machine up in the beginning of the day, and Zero returning it, getting ready for the first part on that day. Notice what I do with the chuck jaws here too. I also, the jaws that I didn't move when I unchucked the part, I back them off just a little bit so that when I chuck the new part, it tends to run more concentric, because it takes the, I don't know, it takes a little bit of the, when you chuck on with a 4-jaw chuck, you put pressure on all the jaws. When you release just 2 of them to chuck the next part, the jaws that you didn't move, you have to back them off just a little bit, and the part runs more concentric when you chuck the new part. I don't know, it's hard to explain. There's extra pressure on the chuck jaws, I guess, and you have to relieve that pressure and then gradually work up to it again. So here I'm putting the next part in there and tightening up the first 2 jaws. I'm going to change to I use tool number 80 on this machine, which is the last tool in the tool magazine, just to do my indicating and such with. So I changed that tool and indicate the part here. You see it's running, it ran within 10 thousandths if you back the jaws off. If you don't, you're going to be running out probably with 30 or 40 thousandths if you back those 2 jaws that you didn't loosen when you took the previous part out. Just a little bit. And here's, I'm just going to indicate the C-axis 0 as well as set the Z, because I know the exact location of this little counterbore I milled in the part here when I did the other end of the part and faced it off. So I'm using that to set my Z0 for this setup. So I face the extra stock off the end of the part that's out by the tailstock end now. So I'm making sure I'm on center line here. That's important to be on center line when you set the C-axis 0. And then here I'm going to indicate that little counterbore, rotate the C-axis and move the Z-axis until I get zeroed in on that hole, the very shallow counterbore I milled in there, and set the C and the Z 0 point at that point. I'm going to move the tailstock forward here and turn a concentric diameter on the OD so that when we put this additional 4-jaw chuck in the steady rest, we'll be running on a true surface with the jaws. So I did a rough turn and I did a finish turn. I may not have had to do a finish cut on this, but I did just to be safe and to have a little bit nicer surface to chuck onto. So indexing the insert and the finish tool. In this material you only get like one cut per tip on these inserts, just about, depending on what you're doing, and you have to index them practically every time. It's not like a job like you can just run it and tweak offsets a little bit. It doesn't work that way on this material because it wears the tools out so fast. So we're back off the steady rest here, and we're going to bring that chuck. I showed this in it was an Instagram post on this chuck. I made this tube that I mounted on the back of the chuck so I could run on the steady rest here, and this is the reason I made it for this job. Although it'll work for future jobs as well. I wanted to talk a little bit about this steady rest that's in my machine, the Mazak over here. I've had a few questions about this, and I thought I would show a little bit about how this thing works, because people have asked me in the comments on how it works. So here's the manual that came with the machine on it, and let's go to there's kind of a little drawing that shows the inside of this thing. It's not a real detailed drawing, but it shows a little bit about how it is inside here. So these are the 3 arms that come to close down on the part here. And in here there's a cam surface that the rollers on these other arms close down, and as the piston here, this hydraulic piston pushes up on this one, and as it comes up it closes down these arms. There's a smaller view here. It shows it without these arms here, I think, are to retract it here, but you can see this cam surface right here. The rollers right up on it. There's rollers on the inside of these jaws as well as on the outside. And as this piston comes up, this cam shape is designed in such a way that it maintains a round circle with the rollers, I guess you'd say, so it holds everything concentric, and whatever the profile of that cam is controls that. So, you know, as the middle guide comes up, it closes these, maintains concentricity. You know, look at this other view. It's kind of like that as it closes. So that's how that thing works. But that might be a little interesting to show that. Okay, here's indicating first tighten the chuck jaws on the two jaws that I backed off. And then we're going to indicate the part in on this second 4-jaw chuck in the steady rest to get it running true. The same procedure. I went into this on a video I made about indicating parts in on the 4-jaw chuck. If you want to see more detail on that, go see that video. But it's basically the same as what I described there. So we got to get this running true. And here's a few shots of just the way the steady rest makes up on the additional 4-jaw chuck with that tubular thing clamped on the back of it. On this kind of machine with this B-axis mill turn multitask machine type of thing, when you indicate a part and you're wanting to find your 0 point in X and Y, it's important to turn the part as you indicate it like this. You see, I've got this black mark on the part because if you have any slight amount of run out, now right now I don't have too much run out. You can see it's like pretty much right on there. And if you had just turned this diameter like it was not supported on this other chuck or tailstock or something like that, you would probably not have any run out, and you could indicate it just straight, just circle around it like this. But I found over the years of running this machine that it's kind of important to indicate this thing and rotate the workpiece at the same time to make sure that you're canceling out any run out that's actually in the part itself when you indicate for your X and Y 0 here, because I'll be doing milling on the face. If it was just a turning job, it wouldn't really matter. It doesn't matter a little bit of run out because you're going to be adjusting the offsets of your tools. But when you're doing milling on the face, it's important to get the run out and indicate it like this, and actually rotate the part at the same time. Okay, here's the first tool, indexing the insert again here to face the remaining stock off the end of the bar. There's about 400 thousandths to face off here actually. I only show the first pass and the last pass on this because the coolant was kind of blocking the camera. So that's the last pass of the rough facing tool. And then first we're going to come in here and drill this 1 1/4 hole. This is a short drill. Let's start with a short drill, checking the point there. Make sure there's nothing wrong with the insert. And I drill 3.5 inches deep with the short drill. And then I come in with the longer drill. And also checking the point. It's got some chips in it there, and I was debating whether to index it, but I think I'm going to go ahead and drill this one more hole and then index it on the next part. These are gurring drills. I've had good success with these gurring drills in this kind of material. So that's going about 9 inches. I think it's about 9 inches deep. It intersects the slot that gets milled later. And here's the rough boring bar. Here, there again, indexing the insert. You only get one cycle per insert with most of this stuff on this material. And roughing out the bore. Kind of hard to film this because of I can't run this without coolant on the setup part on the program, the video I should say on that. I could run some of the stuff without too much coolant and you could see what was happening, but here I can't do it. So you're going to see some coolant in the videos on this part because I just can't avoid it. So that's the roughing boring bar, and then there's an undercut in the bore. And this is the tool I'm using for that. This is actually going to be used also for the finishing cut. But it's just roughing out this recess or groove, I guess you might call it, in the bore. Here's the finish facing tool. Just finish the face with that tool. Now we come back with the same bar to finish the bore. Now this usually takes a couple of 2 or 3 passes actually. I'm just showing you I don't know if this is the last pass or the first pass. I think it's the first pass. But then when I show you with the dial bore gauge, it's actually after the last pass. But this usually takes I usually set the offset down a little bit and run it with the new insert just to be safe so I don't cut it oversized because there's a 2/1000 tolerance on that back bore in there. And I'm also holding it close. So you see here when I measure the depth, it's actually 1/1000 shallow. It has to go a little deeper, so when I offset the tool on the next passes, and this is the final size I came to on this particular part. It has to, I'm also holding it close for this plug I'm putting in here, but the tolerance is only 2/1000 of an inch on that bore that I'm checking with the dial bore gauge. So then come back with a spot drill. And here again, I'm not showing you every one of these spot drills, but just a few of them here because the coolant's kind of blocking the view. But that's the final result of the spot drill. And you can kind of see the bore with the groove in it there, or the recess. Checking the tip of this. This is a 3/8 drill. There's 2 holes that I drill initially with a 3/8 drill and then come back and finish them to 380 thousandths later with a special reamer that I ground for that. This is a 0.422 drill. It's drilling a starting hole for the gun drills. I'm drilling in about, I think it's 3 3/4 of an inch deep with these gun drills. And I change the drill every hole. So I'm going to show you a couple of these holes. I'm not going to show you all 4 of them. There's 4 of these holes. I changed the drills because I can resharpen the gun drill. And I change it for every hole. So I have 4 gun drills. Because it's safer, and the gun drill is very consistent once you get it working. Here's touching off the first drill. And I could set up 4 drills, but you would have to change them anyway, so it doesn't really save you anything. Because it won't drill more than 1 hole into this material. And then I come back with the 422 drill again and drill, and then the 422 gun drill it to depth. And this is 4 holes happen this way. I'm just going to show 2 of them here. But it's the same thing over again for the other 2 holes. And this turns out to be the most reliable, consistent way. I don't have to mess with anything or worry about the breaking a drill. This is a 3/8 of an inch flat bottom. One of those 3/8 holes is a flat bottom hole, so I flatten the bottom with this 3/8 gun drill. I ground flat on the end. So here we are up to this point with the 422 holes, and you can kind of make out the flat bottom on that 3/8 hole to the left. And the finished bore, of course. Now we're coming in with this is the special 380 thousandths reamer. To take the 375 thousandths hole out to 380, there's a plus, it's a -0 plus 2 thousandths tolerance on these holes, so they're kind of close. And I ground that special reamer on my grinder for this purpose. And also it has cutting tips, kind of like an end mill on the tip of it, so that it can touch the bottom of that flat bottom hole and not gall or load up or something. And this is just a 3/8 extended length carbide end mill that I'm using to open up the 422. I changed the tool because I didn't like the way it looked there. The 422 thousandths holes get opened up to 1/2 inch for, I think it goes 1 5/8 deep, something like, or maybe deeper, I can't remember. But it goes in there a ways on the 4 holes there. And then I come in after that with a 1/4 inch end mill, I think, after this. This is what we are up to that point. You can see the 1/2 inch counter bores. You can kind of make out that flat bottom hole a little bit better, maybe. And this is a 1/4 inch end mill. This hole has 2 kind of notches, or kind of off-center notches on each side of the hole. I guess this is some kind of an indexing pin hole in the end of the part. So that's a 1/4 inch end mill milling those. You can see there, they look like. And then there's a chamfer just on the round part of that hole, not on those offset notches. And this is the tool for that. Then this is that special, I ground a special form tool because it puts a chamfer at the bottom of that 1/2 inch counter bore that leads into the hole that gets bored later. And this is a custom form tool I ground for that. And it also sizes the 1/2 inch counter bore more precisely. I didn't show every hole, but you get the idea. This is a 1/32 inch ball-nosed end mill I'm doing the engraving with on the face of the part. This is kind of one of these die sinking, very stub-length ball end mills. I found that they work very good for engraving purposes. So that's the result of that. See the 4 little engraved spots there. It's upside down because the part's upside down right at the moment. It was indexed by the C-axis. And then here's the boring head. This is a heavy metal boring bar. And I'm going to back because I'm going to index the insert. I didn't show that. But I'm going to back the boring head off 1 revolution, which is 4/1000ths of an inch on this particular kind of boring head, this ITS boring head. And I'm going to bore these holes. The tolerance, the size is 0.4375 -0 plus 1/1000ths. So they have to be bored. It goes in there about half an inch beyond the bottom of that half-inch counterbore. So here's the first pass. That's the .4375 ring gauge I have. So I'm going to set my die test to 0 on that ring gauge. There. And you'll notice when I test these holes, that's the last one it bored. You see it's 4/1000 undersized. And that one as well, but see this is actually the first one it bores, and you notice it's less undersized because the insert is kind of breaking in at that point. And it usually takes about 3 or 4 passes with this boring head to get these out to size. And the last couple of passes are actually just kind of like spring passes. You don't even change the boring head. But I showed you the first pass, and I'm actually just going to show you the last one. This is actually the last pass that I made with the boring head. It's doing a bore orient retract cycle, by the way, on this, so it doesn't drag the insert back across the bore. And now when I check these bores, you'll notice I'm just about right in the middle of the tolerance now, which is what I'm shooting for. So that looks good. I'm going to continue on. Here's the plug that goes in the end of the part to support the tail center. There's a pin in it, so it indexes the plug because there's going to be some J slots milled later when we do the OD, and that's what those notches in the plug are for. So it fits good. We take the chuck off. Open the steady rest, take it off, and we're going to bring the tailstock forward. Into the plug. And put the Hamer indicator back in here and recheck the Z0 point. Sometimes the Z0 can shift depending on the pressure on the tailstock because of the give in the spindle bearings. But in this case, it only moves 7/10,000ths of an inch, so I'm not going to worry about it. So that's it for this video. We're going to do the rest of the part on the next video, so thanks for watching.